All right, everybody. So for the third part of this video, we're going to go over some examples of calculating some probabilities. So I know we did something pretty similar to this on the other page, but rolling a six-sided die. So you can have 6 possible outcomes, and if we're just looking for the probability of rolling a 4, 4 represents one of the 6 outcomes. If we're looking just for the probability of rolling a 5, once more, 5 represents one of those outcomes. So the probability is still 1 over 6. But next, what happens if we have multiple things? So it wants to know, what if we roll a 4 or a 5? Well, in this case, that's actually 2 possibilities. So 2 out of the 6 outcomes represent a 4 or a 5. So our answer for that is going to be 2 over 6. So this situation with or, basically adding up those possible outcomes, works for the case of a die. But are there situations where we can't just add those things up? Well, let's take a look. Let's say if we look at one of my class periods, and we look at it by the school you attend and also by your gender identity. So we have some students at Hayes, we have some Buckeye Valley students, and some other students, and then students that identify as male or students that identify as female. So if we take a look at this table, first, we can kind of break this down by category. So if we're looking for students that identify as male, that would be 8 students from Hayes, 4 from Buckeye Valley, and 5 from another district. So that leads us to a total here of, 12 plus 5 should be 17. And how many students do we have overall? Well, it looks like we have 17 students that identify as male, 8 students that identify as female, for a grand total of 25. So the probability that we choose a student at random from one of my class periods that identifies as male is 17 out of 25. Okay, let's look for a student from Buckeye Valley. Well, I still have 25 students in that class period, and now we're just looking for students that go to BV. So we have a total of 4 and 6, so put those together, we get 10. So if we choose a student at random that goes to Buckeye Valley, we expect 10 out of 25 students, or 10 out of 25 times, we'll randomly select a student that goes to Buckeye Valley. But here's the trick. If we're looking for the probability of a student that is either male or attends Buckeye Valley, so kind of like the situation below where it was like a 4 or a 5, now we're looking for a student that identifies as male or Buckeye Valley. If we do this, we're going to see, okay, we have a 10 and a 17, so we have 27 out of 25. And that's actually the wrong answer, because you can't have a probability that's bigger than 1. For a probability, it's impossible. You can't have more than 100% chance of something happening. And the bump that we're running into here is, you might be able to just see it based off of this chart, but you can be both at the same time. You can identify as male and attend Buckeye Valley. The reason why that didn't come up with the die is you can't be both 4 and 5. You either roll a 4 or you roll a 5. There's no in-between roll there. But if we look here for Buckeye Valley and gender identity, it's possible to be both. And that's the difference here. So this is a vocab word that we define as mutually exclusive. And what mutually exclusive means is that if 2 events are mutually exclusive, they cannot happen. I'm going to underline that. They can't happen at the same time. So what this means is, if we have a mutually exclusive event, the probability of A or B means that we just add the things together. We just add the probability of A with the probability of B. So we did that. This is the case of the six-sided die. If we have something that is not mutually exclusive, like our Buckeye Valley example with gender identity, So it can happen at the same time. There's one more step to do this. So our formula for this is now PA plus PB minus the probability that you are both. So in our Buckeye Valley case, we didn't subtract the probability that you are both. So let's go back up top. So first, we need to do the probability of male, identify as male, probability of Buckeye Valley, and then subtract the probability that you identify as male and you go to Buckeye Valley. So we know the probability of identifying as male is 17 over 25 from right here. We know the probability of going to Buckeye Valley is 10 over 25, and now we need to take a look at the probability that you both go to Buckeye Valley and identify as male. Well, there it is. 4 students identify as male and go to Buckeye Valley out of 25 total. And that fixes our issue. Now on top, instead of 27, we now have 23 over 25. And that's going to be our final answer for this probability. So this is the additional step if you have something that can happen at the same time. And that's the idea of mutually exclusive events, is you need to go through